my camera on for a little bit. Welcome to this session. I am recording this just so that you know, so that I can put it on Blackboard so that those of you who might want to refer back to, whatever I'm speaking about, you can refer back to it. And yeah, those who don't attend this evening, they'll also have an opportunity to make use of this resource. So yes, just I'll introduce myself and then I'll just go around the room quickly to see who's here initially. So here are my details. I did this. Oh, I've opened the wrong one. It shouldn't say autumn school. Let's just check that I don't want to have that file open. Let's just check. I should have opened this one. Yes, there we go. So by way of introduction, Rodney Dafford, Marketing Department, CPUT. I'm been around for a little while. I just want to make you aware that I did do this workshop or a similar workshop, but very much a lot the same at the autumn school we had earlier in the year. And that is also on Blackboard under the postgraduate workshops. However, here's the YouTube link already from the previous workshop. And what I'll do is this workshop I will also place on YouTube and Blackboard so that you can have access to the workshop should you ever want to return to it. But just to tell you that there is a workshop where I had perhaps a bit more time than an hour and a half to go through this. I think I had 2 hours, but hour and a half should be enough to give you the basics. So yeah, please feel free to go to that video. Right, a lot more people have joined, but let's just go around the room. We'll start with you can just tell me maybe what you're studying or whether you're a staff member and what your experience is with statistical and quantitative analysis. Laverne, we'll start with you.
Hi, thank you, Prof. Good evening, everyone. I'm Laverne Johnson, and I'm a student in business administration, studying Doctor Business Administration. And my experience is quite limited. So I'm looking forward to the walkthrough this evening. Thank you, Prof.
No, perfect. Prof. Pensula, good to see you again. Maybe you can just say hello to everyone.
Hi, Prof. Good evening, everybody. I'm here to be on a refresher course, and I hope to learn a lot from you, Prof. Thank you very much.
Excellent, great. Mumpu Nado.
Hi, Prof. Yes, my name is Mpo. I'm first year doing my master's in entrepreneurship, and I have no idea what it is, but I have been looking at videos, and some things are foggy when you start listening and whatever. So that's why I attend this program so that I can learn more about these things as I move on forward. Thanks.
Excellent. At least you have the video to go back to when you get there. Miss Julie's, Elizabeth.
Hi, Prof. My name is Elizabeth Julies. I'm also first year master's public administration, and I'm also here tonight just to learn more. Actually, I will even though I attended your sessions previously, I will always attend it if there's another one coming up because I feel the more I go through your videos, the more I want to know because it is a lot to digest.
Yes, okay, good. Thank you. Buyue, boy in the marketing department. Buyue, go for it.
Good evening, everyone, and good evening, Prof. My name is Vuiwe Voia, as you said already. I'm a first-year master's student.
Okay, thank you very much.
My knowledge is also very limited on this concept. I'm looking forward to learn more.
Okay, great.
Like Elizabeth said, I would attend all your workshop all over and over again.
Good. You can watch the videos. Joseph.
Good
Michelle.
evening, Prof. Good evening, everyone. Hope you're doing well. I'm in the proposal phase, first year, Business and Information Administration, doctorate. So yes, I'm also fairly new at this, so looking forward to what I can learn. Thank you very much.
Excellent. OG. Is it, I can't see the name, Chindamana, oh, I can't see it. Are you able to talk? You're still on mute? There we go.
Yeah, Prof, good evening. Yeah, I'm a staff and student, a doctorate student, just a refresher course. Yeah,
Good stuff.
I always like to learn, especially when you are there presenting.
Okay,
Thank you.
good stuff. Great. Nandi.
Good afternoon, Prof. My name is Vunandi. I'm doing my first year in Masters in Operations. I'm looking forward to your session. It's actually the first time attending your session.
Okay, no, good stuff. And Alvis. If you can just introduce yourself, from what course are you and your experience with quantitative analysis, if you're able to talk. You're still on mute. You're not able to talk. And then I see Siba has just joined. If you want to just say what course you're doing and your knowledge on statistical or quantitative analysis, if you're able to talk. Okay, I won't waste any more time though. Thank you so much for the introduction. I'm going to now turn my camera off. So let's get started. So there are notes, and these are on Blackboard already. If you don't have access to Blackboard, you can always drop me an email, duffetr@cput.ac.za. I can send you the notes. Ideally, though, you would like to get access to Blackboard because that way you'll be able to get the video and everything else, but otherwise I am able to email it to you afterwards. You can just take maybe a screenshot of this. Just take note, my surname is spelt with 2 T's, but when I started at Pentech in 1998, they got my email address wrong. They used 1 T. So just take note that my email address has 1 T at cput.ac.za. You can always just drop me an email if you want the notes. If you don't have access to the Blackboard subject, then I'll send it to you. So let's go right in. So it's not a PowerPoint. I actually run it from the notes because I'm going to practically demonstrate and take you step by step through the process. Please just alert me. I don't know if everyone has access, but yeah, it looks like everyone's coming through, so that's fine. I don't have to admit anyone to the room, but yeah. So my philosophy is you learn different statistical techniques to answer the research problems and questions that you want to at hand. It's no use studying a whole 800-page textbook and you don't ever need to use it. You learn stats as you need to. And that's what I've done over the years to build up my knowledge. As I started off sitting with our former statistician, Dr. Corey Ace. And for about a 5-year period, I used to meet with her every 2 weeks and we used to sit down and then I'd ask questions and get her to show me things. And then later on, I went to this excellent professor, James Gaskin. Take note, he's a total guru. He's got a full-on YouTube channel and a website called StatWiki, and he's quite entertaining to listen to. And he's also very good and has lots of YouTube videos. So as you need to know things, you can Google and see if he has a video. If not, there's about 10 other thousand people that have placed videos on YouTube, including myself. So yeah, the majority of research endeavors aim to answer some research, business, or knowledge gap or problem. And so I'm using one of my past master students who will soon actually be a doctoral student. She's had a few years break. And I've used her topic as an example, as a simplistic example to take you through the whole statistical process. So basically, social media plays an important role as a communication and marketing tool amongst Cape Town tourist attractions. And you specifically want to investigate tourist attractions, in this example's cognitive, affective, and behavioral attitude responses. So cognitive has to do with how people's knowledge, affective has to do with people's feelings, and behavioral has to do with people's actions in response to social media marketing or communications. And then you could also collect information on certain geographic, social media usage, and demographic factors, which is not only good for descriptive statistics in whatever research project you are working on, but you can use it to do cross-tabulation versus the actual constructs. And this is where most studies fall short. They just look at some hypothesis, in other words, the relationship between maybe cognitive, affective, and behavioral, but they forget that you can also do cross-tabulation. And this is a problem in most articles and theses. They miss that opportunity because it can give you some very rich data. And I will show you how to do that tonight. So yeah, they use what's called, so in this, the theoretical underpinning of this model is called the CAB model, stands for cognitive, affective, and behavioral, also related to the hierarchy of effects model. And so basically your research problem is, your research gap is to ascertain how tourist attractions use social media and what influence this has on the various CAB model constructs or scales. So your research questions could be as follows. What influence does region have on tourists in terms of the CAB models and social media marketing communications amongst tourist attractions? How do tourist CAB attributes differ across tourist attractions? How do tourist CAB differ across different social media platforms? What influence do social media usage factors, so access and logon frequency, have on CAB attitudes? And what influence do demographic factors have on CAB attitudes? So these are the research questions. And all of you some of you are further on in your research, some of you are just starting. So, you start off with the problem, then you need to develop your research questions and research objectives. And directly from these research objectives, you will develop your data collection tool. So we're focusing on the quantitative aspect of this tonight. And then to go to the hypothesis. So we're saying cognitive attitudes have a positive influence on affective attitudes amongst tourists. Cognitive attitudes have a positive influence on behavioral attitudes, and affective attitudes have a positive influence on behavioral attitudes. So you can see here's your conceptual model. So your theoretical model is CAB. Your conceptual model is this. Cognitive influences affective, cognitive influences behavioral, affective influences behavioral. So these will test these hypotheses. So you can have both research questions that you test by statistics, and you can have hypothesis that you attest. So once you have your research, the advantage of knowing how to do your own stats helps you conceptualize your research questions and your hypothesis, because if you know where you're going to go statistically, you know what you need to put in the questionnaire. So that is the advantage of being able to do your own stats, or at least understand the concept of your statistics. So in order to answer these questions, you need to have a questionnaire that collects the data. So I'm going to, before I go there, you're all happy, you can all hear me fine, and you don't have any questions at this stage. I think what you should probably do is just write down your questions, and then at the end you can fire away. Okay, so let's go to the questionnaire. So here's an example. That's the data analysis. Let's go to that. Here's the questionnaire. So this is the questionnaire she used, or abbreviated version. So the questions are, which region do you live in? So remember, we want to do cross-tabulation with the region people come from when visiting South Africa versus the CAB attitudes, which we'll get to. Which one of the following tourist attractions have you been exposed to the most? Their social media. So these are the major ones in Cape Town. Table Mountain, Victoria Alfred, Groot, Constantia, Cape Point, Kirstenbosch, or other. But these are the big five in Cape Town. So we're going to do cross-tabulation again versus these. Which social media have you used the most? So, okay, there wasn't TikTok or others at the stage. She did this research. Facebook, Twitter, and YouTube were the biggest. And then you have your Likert scale questions. So remember, we have the CAB attitude, CAB. So these first 6 questions, and you could actually put cognitive above if you wanted to, relate to people's cognitive attitude. So it's got to do with awareness, information, and knowledge. And you can't just make up these statements. You need to take these statements from other reputable, accredited research, usually from journal articles. And you can adapt them. You don't need to use their statements in the exact same format, but you adapt it according to your exact topic. So people could have looked at social media awareness in some other industry, but you're looking at a tourist attraction. So very important that you have 2 or 3 reputable sources from which you take your constructs from. So these cognitive are taken from other sources. They are very important because if these don't work, if there's no reliability or validity, you can throw all your questionnaires away. I've had a student that collected, he used some type of research company or this or that, and they collected 3,000 questionnaires for him, and the validity and reliability was 0. We chucked those questions away. He collected another 1,000 and I helped him, actually all online. The same thing happened. The questionnaires were useless. We had to throw them away. But then actually my BTech students at that stage, I'd used these questionnaire for a research project for them. And oddly enough, they collected most of their data face-to-face, and theirs was perfectly reliable and valid. So I don't know what happened then. But these days, the norm is actually to collect questionnaires online because it actually just is much quicker and it makes it possible for you to capture your data much easier. It's a bit easier, but I'm going to show you the manual way because then if you collected it online, it's much easier. Then you have 6 statements. Usually a construct has like 3 to 6 statements. Then you have 6 statements collecting information on their affective attitudes. And she's used a 4-point scale. It's more common to use a 5-point scale. But in her instance, she used a 4-point scale. So you usually have strongly disagree, disagree, neutral, agree, and strongly agree. And some people have a 7-point scale as well, but 5 is the most common. So these 6 statements collect about the affective attitude, so enjoyment, liking, positive feelings. And then the last 6 deal with the behavioral attitudes of, this has to do with intention to purchase, so intention to visit, their visiting behavior as a result of social media. So she developed these from other sources. Then she had some social media usage. So how do you access it? A PC, laptop, tablet, mobile, other device. How often do you visit the social media? What's your gender? These days they have another column, maybe other or something else, but male, female, and your age in years. So these can also be cross-tabulated with these. So this is your questionnaire, and all of this information will be used to answer your research questions and hypothesis. And you can see that everything that we had in the research questions is included here. So once you've developed your questionnaire and now you've collected your data either online or by, in her case, she went to the tourist attractions and surveyed people there, you now need to capture it in SPSS in order to be able to code, capture it in Excel in order to be able to code your data to put it into SPSS. So we'll close the questionnaire. So to show you how to code, I've just taken the questionnaire and it's quite simple. So when you have a questionnaire, it's sequential. So you would label each questionnaire, by the way, 1, 2, 3, 4, 5, 6. So each questionnaire you need to label because it is possible. Well, you'll do that at the end once you've cleaned the questionnaire. So, okay, we'll come to that. So which region do you reside in? You would capture South Africa with a 1, Africa with a 2, and international with a 3 for question 1. So let's just open, if I haven't already, the data capturing template. So how you create a data capturing template is, I think I'm just going to shorten this and call this CT, tourist track. Then I can move this up a bit. That's what I want to do. So at least we can see. Yeah. So here we go. So how do you capture it? You use an Excel sheet. So each questionnaire is captured down here. So you'd have questionnaire 1, 2, 3, 4, 5, 6. So each questionnaire, you number it, right? However many questionnaires you got, use that code. That's the first thing you do, right? Then each question, so each questionnaire is each respondent you have, you give them a number. So the first person you interview would be questionnaire 1, and you're going to capture their data from left to right. Questionnaire 2, you're going to capture their data from left to right. Questionnaire 3 or respondent 3 so that's how you capture. Okay. Then, right. So each question, you need to set this up before. So if I just delete this little bit here, it would be blank. Question 1, you capture with a column. Question 2, a column. Question 3, a column. Each Likert scale you capture with a column. Access. So each question agenda you capture with a column. Right. That's how you. So you set up a sheet like this. Now you actually get your questionnaire. And let me just. It's going to be a bit small if I do the side by side, but let me just do it side by side. And we'll minimize this and we will make this a bit bigger. Take this down and show you. Let's just make that a bit across there. Right. So let's just say this is the first questionnaire and someone's completed it. So which region do you reside in? If they tick South Africa, you capture it with a 1. If they click Africa, it's a 2. If they click international, it's 3. So let's just say this is questionnaire 1 that someone's completed. And okay, we haven't even got to the cleaning yet. I'm kind of jumping a whole lot of things in my notes. Let's just see what's hypothesis. Okay, we're not even there. Questionnaire cleaning. Okay. So just before we even do what we're doing, once your questionnaires are complete and you've collected them, the first step is to check that there's no gaps. If there are gaps, you need to see how you can rectify. If there's too many gaps, you need to chuck that questionnaire away. Secondly is to code your questions. So that's what I'm going to show you now. Third is to write the relevant codes next to the Likert scales if it's a manual questionnaire because it's faster to capture. And then lastly, you number your questionnaires, right? So that's how you can clean it. 1, 2, 3. You write your codes next to the Likert scales. So just to show you, you'd write the codes 3, 2, 1, whatever their codes were next to it when you manually capture. If you've done it online, it's easier. So let's go back to these notes. And then we get in catching up to where I was. The process is much faster for online. So if you collected it via Google Forms, you need to code it. You can just, if they clicked agree, you can just find and replace all agrees with a 3. And then that's easy. You just cut and paste it in your Excel sheet. So, you know, I don't have time to actually show you one by one like that, but it's the same principle. You would figure it out. Then you need to capture it in a data Excel sheet. The use of a separate column is used to capture each question. So refer to the questionnaire, which I'm showing you. There should not be any gaps in the capture of datas. Check each column. Okay, that's the end. And you capture the data as I showed you from left to right. Okay, so we've caught up on the notes. So here's your template. You've captured each question by a column and you've numbered all your questionnaires. So you've sorted through the questionnaires. You've chucked those questionnaires you can't use. And then you've numbered your questionnaire 1, 2, 3, 4, 5. And now we need to open this. Here's your code sheet and make it a bit bigger. Right. Now, maybe not that big because I need to see that. So for the first question is so they either select South Africa, Africa, or international. So let's just say it was an international student, you would capture this, if this is questionnaire with a 3. Then, which one of the following tourist attraction sites have you been exposed to the most? So let's just say they say Victoria Alpha Waterfront. Then you would capture it with a 2. And let's just say which social media you use. We use Facebook. Now you get to the Likert scale questions. For each question, if they said strongly agree, it's captured by a 1. If they say disagree, a 2, agree, 3, strongly agree, 4. So now you capture, let's just say for this first few, they said agree, agree, strongly agree, 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 disagree. And then you capture the next. So let's just say they agreed for most of these, and they maybe strongly agreed that they were positive. And then the behavioral, let's just say they were a bit more, disagreed that it really had an influence on the behavioral. So that's how you would capture it. And then access, let's just say they use their mobile phone to access it. They log on multiple times a day. Their genders are female. Their age is, let's just say they're between 26 and 35. You capture it with a 2. And there you've captured the first questionnaire. Okay. There should not be any gaps in the questionnaire. Yeah, so that will go back to my notes. So that's how you capture a questionnaire. And then you would go to questionnaire 2. And you would then do the same thing. You'd capture in the next column. So we can just minimize this, maximize this. And so we'll just undo all. And then ultimately, it's going to look like this, your data. So this sample size had, it had 384, which is the ideal sample size. With a 384, you can sample the whole world if you go to the stats calculator. So this is what it's going to look like, a whole bunch of numbers. But if you get any numbers wrong, it's not going to work in your SPSS because you're going to program these codes into the SPSS as you see. So a good way to fix it is, for example, let's just take these. If you have captured some with a 5 and some another one with a 5 and one with a 7 and one you've got a gap there and you've got another gap and you've got another gap and you accidentally type the 22 here. So once you finished capturing the data, what I suggest you do is you just position your mouse on, you first save it and then you save it as something else, because I've had students that have done the totally wrong thing. In other words, they blocked the column and they sorted each column by itself, which means that it took the questionnaires out of sync with the respondents, and you have to keep them in sync because this is respondent 1. If you sort the column, you're going to take his response out from where it is. So you just don't block the column. If you say block the column like that and you click sort, it's immediately going to say, let's just say smallest to largest. It says expand selection or continue with current, because it knows it's going to, if it gives you that, cancel. You just put your mouse there. Now you want to check that these codes are not outside the code you captured. You just go sort, smallest to largest, and then you scroll all the way down to see, are there any problems? And here it tells you yes. You see, that's why you have the questionnaire number. Oh, questionnaire 8, there's a blank. And now you need to go back to questionnaire 8. That's why I tell you to number your questionnaires. And you see, oh, they actually gave a 3. Then you go to the next column and you go smallest to largest. And you scroll down and you check, oh, there's problems in questionnaire 3. You had a 22 for 4.0. You see, oh, that should be a 2. This was a blank, and you say, oh, that should have also been a 3. And then you go to, so it doesn't take you long. You just sort smallest to largest each column to check that they're within the code range. And here you can see that's all fine because it only goes up to 4. Go to the next one. I made a few more mistakes deliberately. 4.4. Go all the way down. Oh, there's a 7. Is there a code? No, it's either 1, 2, 3, or 4. With 4 being the highest. So there's a mistake. And if you go back, you see, oh, yeah, it should have been a 4. And then you sort, and so you sort each column to check that the codes are in the range of your data capturing. Within one, the code can only be 1, 2, 3, or 4. Some people also accidentally hit another key with it, and they have a they often capture like a 4 like that. That's also going to create a problem if you have an inverted comma with SPSS. So you just need to capture them as single numbers. Okay. Once you've captured all your data and you've cleaned it and you've fixed all of your Oh, I just want to show you something. And then once you've finished sorting, once you've corrected all your errors, you go back to questionnaire number and you sort A to Z, and it puts it back in the correct order, 1 to whatever. So you want to keep that order. In case there's any mistake, then you know which question it is. So that is before you even get to SPSS. You don't need to have done anything in SPSS. You capture your data in Excel, or if you've got a Google form, then you need to convert it to this format so that each questionnaire is a column. However, there is a complication. I just want to see where I've raised it. Oh, okay, I will raise it in SPSS. Okay, so that's the data capturing like in record time. This is what your data is going to look like. So we'll just want to undo all of these things quickly. So this is what it's going to look like, okay? Like this. Then now your next step is you're actually ready to go to SPSS, and it's Michaela Marcheman is the person you contact. If you want to get an SPSS license, he's with the Research Directorate. So if I just quickly go in, I'm sure his details are on the CPUT website. Let's just show you if you want to get the license for SPSS. You go in, you go to Research Directorate and Development, Staff, and Patricia. Let's just see. I don't see his details here, actually. Not up to date. Sorry. Sana, he's gone. Gone. Okay, not up to date. But it's Mark. It's Michaela Marcheman. You can speak to your supervisor or whatever. He will be able to get it. Michaela Marcheman. And it's a he. So he'll be able to help you with the license, or you'll speak to your supervisor, or, you know. So now, once you've captured all your data and you've cleaned your questionnaires and everything's numbered, you're ready to go to SPSS. And this is what SPSS, this is the coding sheet. So unfortunately, I can't make this any larger. It doesn't really, unless I, yeah, it doesn't want me to, yeah, can't change it any bigger. And there's two views. There's the data view. This is where you're going to cut and paste your data. And there's a variable view. This is where you program your questionnaire into SPSS. So let's just take you through all of this, all of the different processes. Not really difficult at all, but let me show you. And I can actually perhaps just see let's do that. So we're in variable view, and I can open the notes next to it. Okay, and we'll just zip that across, make that like that. So we'll just go over that a bit and make this a bit smaller. Okay, that's a good size. So select the variable view as I've showed, just to check you can see both screens. Hey, you can see the notes and the SPSS together. Just to confirm from someone. Just to confirm, you can see the SPSS here and the notes on the other side?
Confirm, we can see it, Prof.
Perfect, thank you. So select the variable view tab. So we've selected the variable view tab. Okay. Now you're ready to actually code it, and you're going to use the coding questionnaire, which I showed you for each question. Okay, so if we go to firstly the name is captured in this. You use a summary of your each question here. So each question is captured, you know, down. Question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's captured down like this. So you can see if you look at the label here, here's the question, which region, which one of the following. So if you look at the label, you can cut and paste each questionnaire over here. I'm just jumping the gun a bit. So you can capture it. But if we start off with the name label, you just provide a little summary name that will help you identify this question because there's different views. You can decide whether you want to see the name and the label, or whether you just want to see the name or just want to see the label in your data analysis later. So you need to decide what you want to see. But so you give it a short name. So for region, you could call region. For Cape Town Tourist Attraction, you could abbreviate CT Attract. But remember, there can be no gaps here. There can be no spaces in the name column, because if there's a space, it's going to give you a error message. And then your question on which social media sites have you, maybe I must just make this a bit smaller, and then I can, so, and then your cognitive, your 6 cognitive statements, you could call cog 1 to 6, and you can, your affective, you can say affective 7 to affective 12, behavioral, and so forth, each question. These, I'm just going to delete these for now. Clear. Okay. So you capture each question with abbreviated label without spaces. Then under the different type, so that's your first step. Let's just catch up to where I am. Question. Type is generally numeric. So you would select, it gives you a choice, numeric, comma, dots, blah, 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 etc. You generally select numeric. Okay, for all of them, you can see it's numeric. Unless you have open-ended questions, you can have string. But I don't ever use it. I've tried, it just doesn't, but that's how you'd capture open-ended questions generally with string. But SPSS, you're really not using it for open-ended questions. My students are always advised to have 0 open-ended questions. Always give them an option, unless you want to do some qualitative analysis afterwards. And you kind of have a mixed method. So you have a quant section and you have a qual section. But SPSS can't analyze qualitative data. You use Atlas TI or something else. So all your questions are numeric. All the questions are width. The width is all 11 or whatever. It doesn't really make a difference, the width. Decimal places, generally you put 0 decimal places, because SPSS will, generally SPSS gives you 2 and 3 decimal places. So if you say 2 here, then it's going to give you 5 decimal places, which is too much. So you just make the decimals 0 here. Then say each question is captured in its own line. Sorry, someone's not on mute. Please mute yourself. So each question is captured by a line. So you can go to your actual questionnaire. Oh, we don't want to open Word. We want to go here. And if we go to the questionnaire, and so then you can take this, which region do you reside in? And you can just go copy and you can put it there and you can go paste. You see, and you can actually label it if you want to. You can say 1, 1. You see, which one of the following, and you cut and paste. These are easy to capture. You just, your Likert scales, you just take all of them and you go copy, and then you can block all of this. And, you can cut them all in one go like that. And you go and you can paste it all. Okay, I'm struggling to, paste. Oh, but okay. It's because this it's taken my numbers. So let's just go undo. Okay, but you can in Word, if you have it in Word, it took my numbers, but you cut and paste. So you cut and paste all your questions here. That's quite easy. Then the one part that actually takes a little bit of time is to now program the numbers in. And this you do under value. So you click on the dot, dot, dot. So you click on the dot, dot, dot here, and now you need to program it in. Okay, so it says click input. So let's just clear all of this so you can see. So it's going to be blank. And then what you need to do is program the codes in. So you say plus, the first value is 1. And what's the label? What is 1 equal to in the data capturing? So let's just go back to this. So if you go to the first question, 1 is equal to South Africa. So you type in South Africa. Right, then you go plus. The next one for questionnaire 1, or for this question, is 2 is the value. It's always going to be 1, 2, 3, 4, 5, 6. And then you're going to code it with Africa. And then you go plus, and the next code is 3. And it's, if you look at this questionnaire, it's international. So then you type in international. And then you go OK. And then you can see there it's coded. And then you go to your next question. In this case, codes 1 to 5 or 1 to 6. And now you can, if you click on these dots here, then you can see I've coded 1, 2, 3, 4, 5, 6. You know, each value you just code. And then this as well, you can see there's codes 1 to 4, Facebook, Twitter. So you've coded this. And then the Likert scale is easy. 1 strongly agree, 2 disagree, 3, 4 agree. And then once you've coded this, you can just literally copy this into this. You can go copy, and you can go paste. You see, it just pastes. So then you can paste, and then you code the rest of the questionnaires as they are. So if you go down here, for PCs 1, laptops 2, so you code all of these in. Okay, not too difficult. I just need to, okay, I won't clear those yet. Leave them. Right. So you code it. Missing, you want no variables missing. I don't let my students, if they've got missing variables, you have to try and fix it, find the missing answers, or chuck it away. Columns, let's go back to the notes here. So we don't need that anymore. Close that one. So columns, generally 8. Alignment, generally right. And now the measures is an interesting thing as well. So nominal measures, it's not so important, but nominal measures, it doesn't have a meaningful rank. Like gender would be nominal. Where do you reside is nominal. Which social media sites is nominal. There's no rank. That next question there is which social media do you access most? There's no rank. Nominal is no rank. Gender, place, platforms, you select nominal for that. Ordinal is where there is a rank. So in other words, strongly disagree, agree, strongly, there's an order. So then you just label all of these ordinal, and then the rest, you know, nominal, ordinal. Scale is where there's a distinct actual value. So if you captured age, you see I captured with nominal because we had age categories 18 to 25. But if I had 1, 2, 3, 4, 5, 6, 7, 8, 9, then I could have used scale. Okay, but that's just how you program. It has a little bit of an influence on the statistical analysis, and the role, it's just input. Okay, so that's, now you've programmed your questionnaire, and this is what it looks like when you're finished. Then you can go to data view, and now I'm going to make this, just get this out here, make this full. So now what you need to do is you need to cut and paste your data in here. So what you would do is you go to your Excel spreadsheet, and you take your questionnaire number, and you take your age, and you go from 1 all the way down 384. You go copy. And then you'll just position there, and you just go paste. But I'm not going to click paste because it'll take a while. And once you pasted it, here you go. Now you're ready to start. These, I won't delete them. They aren't here. We're going to compute these later, these 3. Right. So now we're ready to start. It's taking me 45 minutes to do that, but the analysis is much easier. Now we're ready to do the analysis. So let's just go start doing the analysis and not waste time. So we can, don't save. Nope, I don't want it. We want to keep the notes open. We just want the notes open, and we just want that. Okay. Maybe make it a bit smaller. It's too big. Right. Now we're ready to do the statistical measures. Okay. You're ready to commence. However, before you start, select tabs, option, output, outline, labeling, variables. I prefer to use names and labels under the variable values. I prefer to use labels because this has an influence with your how it's going to display. Then under pivot table labeling, variables, items shown as, I prefer to select names and labels, and here I expect to use labels. So where am I talking about? Let's just show you an SPSS, edits, options, and okay, I don't think I wanted to go there. Let's just minimize this so that I'm in it. Can do this next because I've set this all up already for myself. So we want to go to edit, options, output. Okay. Edit, options, output, and here you see I've selected under out labeling, I've selected names and labels, and here I've just selected labels, and here I've selected names and labels, and here I've selected labels. So that's how I like to set it up. It's just got to do with how it displays under pivot tables. I was just saying how we need change. Yeah, pivot tables, labeling, variables and items, I prefer to use names and labels. Okay, never mind that. Yeah, the main one is this output. So just get this output right, but you can change it how you want to see your data. It just has to do with the headings and the side headings as well. Okay, let's maximize that. So you can, however, you can change the names and labels to names or fact for the fact analysis if you intend to use pattern matrix, but structural equation modeling, which we definitely won't capture tonight. Now you're ready to begin with your stats. So the first thing I ask, I tell students to do is to do the frequencies. This will show if there's any missing information. And how you do this in SPSS is you select. So you've got these steps you can follow afterwards, but you click analyze, descriptive stats, frequency, and then you move variables across, and then you click OK, and then you export files. But instead of me reading through all of this, I'm just going to show you how to do it. That's the best way to do it. So now, and we definitely don't want that open. And we don't want that. We want to go there. Okay. So to analyze, this analyze is where you're going to do most of the business. So you click analyze, you scroll down to descriptive stats, and you click frequencies. And you want to do frequencies of everything for now. So you scroll down, ignore those last three because we're going to create them later. You block it. So you put the mouse there, you click shift, put your finger on shift, and then you use the down arrow. Okay, that's how I'm doing that. Put the mouse, highlight it, put your finger on shift, scroll down, and you go all the way down to age. Those three will create later. And you click it across. You don't need to do anything more else. You go, okay. And here it's giving you your descriptive stats. It shows you immediately, are there any missing data? And because we've checked it before, there's nothing missing. It will also show you if you had like a label 4 here accidentally, it will then have South Africa, Africa International, and a 4. So, that means you then need to go and find and sort that out. So if you have any codes out of sync, it will have a different option to your label. So you can see this is how it labels. This is how all your stats are shown instantly, all your descriptive stats, and you can use this for your graphs. So then you want to export this. So you go File, Export, and you always export this as a Excel file. Okay, Excel is the best way. Then you browse, you select wherever you want to place it. So let's just say we want to go to C. I'll put it here, and I'll put it under Internet, and we'll just call it frequencies. and we go save. And then you go, okay. Now it's going to export this data. Okay, once it's exported, we'll just actually go to internet, and there you go. There's frequencies. This is what your data is going to look like. Okay, it gives you all this gobbledygook and stuff, and you don't need any of this. So what I do is I just, from the first question, I just clean it up, I delete it. Okay, so here it gives you the frequency, the percent, the valid, the cumulative percentage. Generally, a lot of people are interested in the frequencies. That's important. So, you know, I delete that column and I delete that column. And then you're left with just the valid percentage and the frequencies, right? So you can use this how you see fit. But when you want to create your graphs, which most have, then just save it as another name, and then, you know, you can delete that. Now you're ready to make your graphs. So if you want to make a pie chart, you just go, you know, insert. You want to make a pie chart. Let's just say that's your pie chart. You delete the label, you right click, and you add your data label. So there's your, you know, that's how easy it is. And let's just say you want a pie chart here as well. Insert pie chart, you know, delete the label, right click, add it, and there's your graphs. And so it's easy. So you can create your graphs. Maybe you want a bar chart for this. Insert bar chart, delete, right click, add your data labels, and there's your graph. Okay. However, for the Likert scales, it's different. You don't want to just do a graph for each Likert scale. You want to group the scales together. So I would write code. So this is in C36. So I'd go equals C36. It's going to bring it up. This one is in C34, so 44 equals C44. I think they go in 8s, so 6s equals C52, equals C52, and 52 equals C52, and I assume this is equals C60. If it's, yeah, C60, and the sixth one for the 6 is equals C68. You'll see what I'm doing now. 68, enter. Let's just make these a bit thinner. And then what you can do is just block it and drag it down like that. You see, then it's taken all of these variables up, and you can repeat the same for affective, the same for cognitive. Then what I do is I immediately take these labels again, and I put them there. And then I write a little formula equals sum that. I take these 6 variables, I put my brackets there, I divide by 6, and now and I right click and I say format, because we don't want so many decimal places. We say number, we want 1 decimal place, and we go okay. Then you drag this down. Now what you've done is you've calculated the weighted average of these 6, because that's called a construct. So each Likert scale combined is called a construct. Now you can block this, and you can go insert, and you can say bar chart always for that, or not bar, recommended charts. We'll say bar chart. Okay. Delete the title, right click, add data label, and there's your graph. And then you can say 6 Likert scale computer, use 6 Likert scales to compute the weighted average of the cognitive attitudes towards, you know, that would be your graph. And you do that for the other 3. So that's how easy it is to create your graph, and that's how you use the frequencies. So in every thesis, not in journal articles, you don't use graphs generally, but in theses you do. Okay. Don't save. And so that's the first little statistical test done. Okay. The next one is descriptive. So often you want to calculate the mean and standard deviations, because often a thesis has a table with your Likert scales, and they have the means and standard deviations. You want to know that. So to do that, it's analyze descriptive stats, descriptives. You're going to uncheck minimum and maximum, only check mean and standard deviation, and then, yeah. So let's just show you that, because sometimes you want the mean values. So let's just find my way back to, so this output, you can save these outputs as well if you want. You can go to file, save as, but generally you don't. They're so quick to generate. No. So now you want to do the descriptive stats for the Likert scales. You go down, analyze, descriptive stats, frequencies, descriptives. Now we want the Likert scales, because sometimes you want these mean and standard deviations. You just block and click. Then you go to options. You want the mean and standard. You don't want the maximum, minimum. That's all we really want. You go continue. You go OK. And here's your table, the mean and the standard deviation of all your different values that you could use this in a table. To export, you just go File, Export, Browse, wherever you wanted to browse, and then, save, etc. I'm not going to show you how to do that each time. Showed you the one, so you just export it. So that's the other stats that you could use. These are just the basics. We want to get to the nitty gritty. We'll probably go over a bit over 5:30. 6:30 may end up going to 7, but we'll see. If you have to go, you have to go. Right, so that's the descriptives. Now, it's very important to determine your reliability of the constructs, the Likert scale. So you have 6 statements for each. And what reliability is it measures the internal consistency and reliability of the data. So a scale that's administered twice to the same respondents on different occasions should yield the same results. That is what would be reliability. Internal consistencies agree which the scales measure the same attribute, which is measured by Cronbach's alpha. And so all of you who are doing quantitative analysis will have Cronbach alpha. There are other measures, but this is what you use. So to do this, there's a whole procedure. Analyze scale, reliability analysis. You choose the Likert scales that you want. I'll show you. Then you say statistics if scale deleted. I'll show you continue scale labeled looks repeat for cognitive and behavioral. The value should be above 0.7, and you find literature to substantiate that. And sometimes you need to delete a certain variable to increase your reliability, but you only do that after you've checked the validity, which I will show you later. So let me show you how to do the Cronbach alpha for the 3 constructs, being the cognitive, affective, and we haven't got to the research questions yet and the hypothesis, but that's coming. So you go analyze, everything's just about everything, scale, reliability analysis. The first one you want to check is the 6 cognitive scales. Is there reliability? You block them. You move them to items. You type the label below cognitive under here, and statistics. We want to click scale if items deleted. That's going to show you if you delete one of these 6 constructs, is it going to improve the reliability? And sometimes it is the case. You click continue, you click OK. And here it's given you 8.62. It's very good reliability for these 6 statements. And now you can check if the item is deleted, is there any that's going to make it stronger? 847, 848, 831, 831, 831, 835. No. So these 6 together give you the strongest reliability. And so you could very quickly repeat this process for the others, and we can do that. Reliability analysis. We don't want these. We just block them. We send them back. We send the next 6 in, block them, send them in, change the label. We'll just say effective. You don't need to click the statistics again because it will remember, and you go, OK. 8.13, and if you look at the 6 items, all of them are below 8, 783, 793, so it's the strongest as it is. And if you do the last scale, reliability analysis, we take these 6 out and we put these 6 in, and We quickly type behavioral. And we go, okay. And 8.71, very good. And 865, 857, none above 8.7. So they are perfect. And then you could export this, but really the only three values you need is the 862, the 813, and the 871. And later on, you're going to see there's a table that I show you, which you'll see in just about every journal article. Where is it? Here it is. You'll see this table in every journal article. So you see, you can already include your mean values here in this table. Most journal articles, you can include them. We've calculated them. And now you can include your Cronbach alpha values. So this attitude scale shows you the mean, standard deviation, factor loading, AVE, composite reliability, and Cronbach alpha. You'll just look at this table and you'll recognize it. If you've read lots of journal articles, quantitative articles, you'll see this is what they do. So you've already done mean and standard deviation. So if you can produce and understand this table, then you understand a lot about enough to finish a master's and a doctorate in terms of statistical analysis. So there you've done the Cronbach alpha. And it needs to be above point. Right, so that's the reliability, and they need to be above 0.7. And you just say, we did a Cronbach alpha analysis and all the variables were above 0.7, therefore it's acceptable reliability. Now for the other analysis, we need to create groups. We need to combine the 6 statements from the cognitive into one scale, the affective into one scale, and the behavioral into one scale in order to be able to do the cross tabulations to start testing for significance to see if there's significant differences in order to answer the research questions. And I tell you how to do it here, but the easiest way is just to show you how to do it. So we go into, we delete this output, we're not going to export, and we go back in. So here you go to transform compute data. You can type in your first variable, cognitive, we'll call it cognitive 1 because I've already done this, okay? Then you go to the function group and you double click on statistic, or you click on statistical, and then you double click on mean. And then it gives you these brackets here. And then what you do is I just delete the brackets. You can bold them and you double click on cognitive. Whoops. And it comes in, you click comma, you double click on the next one, comma, the next one, comma, next one. Oh, doesn't matter if they're not in the same order, comma, we've done 4, 5, we go comma, and we've got 6. There we've got all 6. Now what it's going to do is calculate the average of these 6 statements for each respondent. It's going to calculate the mean value, but for each respondent separately. And it's going to create a new variable in your variable view. So you click OK. And then you repeat the process, transform for the others. So you go compute variable. Now we just block this and you just click delete. We change this to effective 1. Oh, no spaces, sorry. No spaces there in that target variable. And then you just double click 7, 8, whoops, comma, whatever must, no, I haven't missed any. Have I got a space there? Mustn't be a space. It is a space when problems. Put the cursor there, double click on 9, double click on 10, double click on 11, double click on 12. So now we've got all 6 variables, effective. We click OK. Then you repeat the process for behavioral. So if you now look under variable view, you'll see it's created these new variables, right? But then you need to, and then you do behavioral as well. Then just change the column. You just click on it and you click here on the arrows and you make it 11. You take away these decimal places and you don't do anything here. It's created as scale. It doesn't matter about the columns, whatever, you can leave that. So I'm just going to delete these 2 variables because I've already done this. And so now it's created these three variables. And if you go to the data view, you can see at the end, it's created new columns, cognitive, affective, and behavioral, and it's calculated the mean value for the 6 cognitive statements here, the 6 affective, and the 6 behavioral. So you need this for the cross analysis that you want to do, because if we go back to our research questions, what influence does region have on the CAB attitude? So cognitive, affective, and behavioral. You can't do it for each individual Likert statement. They need to be combined into one, like you did in your graph. So you need to get the mean value. So now you can compare region to each one of these. You can compare the different tourist attractions to each attitude. And you can compare the attitudes towards the different platforms and their demographic and usage factors, which I'll show you how to do. And there's different statistical tests to do this. And what cross-tabulation, most people have no cooking clue how to do it, but it can give you such meaningful data. So that is what I'm going to show you now to answer these research questions. And right, we've done frequencies, descriptive, reliability. We've created the groups for the 3 constructs. Naturally, you could have like 10 constructs, you know. Yeah, and you're not limited. It depends on your model. So the first test you can do to test whether there's a significant difference. Now, yeah, we're going to get to that, is a t-test. This can only compare 2 groups of respondents. So if you have male and female, or yes and no, you can use a t-test to see if there's a significant difference compared to whatever you're comparing it with. In this case, you're comparing it versus each of the CAB attitude constructs, and there are 3 of them. So there can only be 2 options in the questionnaire, yes, no, or male, female. You use the t-test. And here I tell you how to do it: analyze, compare, you know, independent, mean, select. I'm going to show you how to do this. So the only variable in our questionnaire where there are 2 variables in the example is gender. So if you want to compare whether there's a significant difference between male and female in terms of do their cognitive attitudes differ towards social media marketing on tourist attractions, their behavioral and their affective attitudes, do they differ? So we can go and do those t-tests. Let's have a look. So you go analyze. We want to go to compare means and proportions. Okay, compare means. And we want to do I think it's an independent sample test, yeah? Independent t-sample test. Let's just check that's the one I want to use. T-test, compare, yeah, independent t-test. Now, and if you just, I don't use t-test much, so select the Likert group and move it to the test variable section. So we want to compare cognitive. So you don't do the individual cognitives. You take these new variables you created, cognitive, affective, and behavioral. We move to this. The grouping variable that we want to compare is gender. So remember, there can only be 2 respondents, so you can't use a t-test for any of the other cross-tabulation. Then under define variables, it's 1 and 2. Group 1's 1, group 2's 2. That's fine. Continue, you click OK. Now it gives you the results. So firstly, is there significant difference? 0.995. So let's just show you what we're looking for. SPSS, SIG. So if the value that it gives you is between 0.000 and 0.01, there's a significant difference at p equals less than 0.01. In other words, there would be a difference in terms of male and female. Their views would be different in terms of social media marketing towards tourist attractions. Would be very different. If it's between 0.02 and 0.010, there's a significant difference at p equals less than 0.01. And if it's between 0.11 and 0.050, then it's significant at p equals less than 0.05. If it is between 0.51 and 0, there's no significant difference. In other words, their views towards social media and their cognitive attitudes, there's no difference between male and female. So take note of this little table. So if we come back to the findings, you can see that it's 0.95. There's no difference. You usually also report this t-value. Here it shows you the means. Males' means were 3.16. Females were 3.12. You could quickly do the others as well to see if there were any differences. Compare means, one test sample. We throw out cognitive. We throw in effective. And we check, is there any difference? 0.921. 3.24, 322, the means of the, and we could do the last one just to check if there's any difference. Compare means, one sample test. Selected the wrong one. Analyze the independent test. Throw out effective. Put in behavioral. Okay. And the significant is 0.105. Closer, but still no cigar. 320, 321, the means. You can see there's no differences. Negative t-value. How would you report on this? You would report the significant level. You report the t-value. You can report the means and the standard deviations. And I'll show you in the notes how you would report on this. So you would say the independent t-test revealed no significant difference. You give the p-value, which is sig. The t-test between males, you give the mean and standard deviation, and females, you give the mean and standard deviation. In terms of cognitive attitudes attributed to social media usage, marketing communications usage by Cape Town tourist attractions. And you would have the same report. So the important values here are, the mean and standard deviation, the sig value, and the t value. That's what you report on. And so you would write it up like this. I've shown you how to write it up. Okay. Not too difficult, actually, just practice. Please note the significant values. So I've already shown you what the significant values are. When there's more than two groups, so that's most of our questionnaire. If we just open the questionnaire quickly, if you open the questionnaire, you'll see how many options are here. There's 3 groups, South Africa, Africa, International. There's 5 groups here. There's 4 groups here. Okay, those are what you're comparing to. 3 groups, 6 groups, 2 groups you do t-test here. There's 5 groups. So now you can use ANOVA to see if there's a significant difference, for example, between the cognitive, affective, and behavioral attitudes in terms of whether they are South African tourist, the African tourist, or international tourist. What do you think you would find? Well, you use ANOVA to do that. So let's just close this. So ANOVA is used to compare more than 2 groups. ANOVA compares the variance in groups, and a large F value means that there's a great difference between the groups. A low F value means there's not. You also use a post hoc test called the Bonferroni. In other words, this shows you between which groups the difference is, because there's not 2 groups. If there's 2 groups, there's a significant difference. It has to be between those 2 groups. But ANOVA just shows you if there's a significant difference, where Bonferroni the post hoc test will show you where the significance difference is. If you use ANOVA to compare the means between only 2 groups, then the post hoc test will not be performed, because there are fewer than 2 groups, because obviously then it doesn't need to show you where the difference is because there's 2 groups. So yeah. How do you do ANOVA? It sounds complicated, but it's not really much. So you select analyze, compare, one-way ANOVA, select the group, move the dependent variable into factor. Select post hoc Bonferroni option descriptive. Okay, so I'm just recapping myself, because again, I don't really use this test very much. I prefer other tests. No, but ANOVA is very commonly used. So now we want to compare. Now we're starting to answer the research question. So the first research question, is there a difference in region? So we go compare means, we go one-way ANOVA. Okay, the dependent variable that we want is cognitive to start off with. The independent variable is, you just select region, is the factor. Contrast, we don't want any contrast. Post-hoc test, we want to select the Bonferroni is what I generally use. Options, we do just want to see the descriptives because we need that for the means and standard deviations. Continue, that's it. So you move cognitive there, region there, post-hoc, you put Bonferroni, options, you select descriptive, and then you click OK. And what it shows you here is it firstly gives you ANOVA gives you the mean values. You can see they're close, 3.16308.311. It gives you the ANOVA, so it gives you the significance, 431. In other words, there's no significant difference because it's above 0.0.50. It gives you a very small F value of under 1. And then it gives you the post-hoc test, which shows you, is there a significant difference between these values? And if there was, it would give you a little A or asterisk there. And there's nothing because it's telling you there's no significant difference, 4.31. But let's have a look and see where there is significant differences, because I've already, so that you can see what it looks like. No, we don't want to. So if you scroll down by the notes, I've already done some of these tests. So you have to do it one at a time here. So under access, there's definitely, and log on frequency, there's significant differences. So let's just do those stats. Analyze, compare means and proportions, one-way ANOVA. We want to do COG, we want to throw region out, just block it, throw it out. And we want to check access, there was a difference there. So we click it in. So you need to do this, but I mean, I'm just showing you need to do this for each variable. So you need to put in cognitive and then do region, Cape Town attraction, SME. Then you need to put in log on frequency, gender you've done already, and age. You see, and then you need to throw out cognitive and put in effective, and then put in these one at a time. And then you need to throw out effective and put in behavioral, and then put in these one at a time to run. So you run the test like 24 times or however many tests you're doing. If you look at this table, to get each of these values, you go 1, 2, 3, 4, 5, 6, 7 independent variables and 3. So 3 times 7. So you need to run this test 21 times, and then you would put the significant value, you know, for each one. And those that are significant, I'll show you, though, you use the stars. If it's significant, 0, 0, 0, you put 3 stars and you put a little key here. If it's significant, like that's 0.50, it's below 0.50, then you use 1 star. If it was between 0.002 and 0.010, then you'd put that and you'd put 2 asterisks. So you have to run this test 21 times. But it's you see, it's very quick to run, and then you put the values in a table like this. But let's just now run access. We don't need to click the post-hoc or options. It remembers. You click OK. And here it gives you the table. So it gives you the mean values. Now you can immediately see here. You can be suspicious that there's going to be a significance because look at the mean values of PC and laptop are way below tablets and mobile. And sure enough, here it shows you significant value at P equals less than 0.001. So there's your sig. The F value is 8, so it's a bit bigger. You see the other one where it was insignificant was below 1. So you're going to report on that. And here's the post-hoc test, and it's showing you it's very small, I know, but you can see PC, it's got a little star next to tablet and mobile, which means that PC is significantly different from tablets and mobile. I just can't make this bigger, but what I can do is if I export it, that will show you. Then I can go into an Excel sheet. I need to do that. And let's just stick it in C 2024 internet, and we just call this access cog. You can run all the tests in one sheet and then just export it in one sheet. But I'm not going to do that. You can run test after test and I'll show you and then export it. But we'll say save. We'll say okay. So export it just so you can see it. And you always export it as Excel. Well, let's just do another few tests as well. Analyze, quickly compare. one way and over. Now we want to do the same test for, we throw out cognitive, we throw in effective, we go okay, and then we just go analyze. You see, it's very quick. Compare means, one way and over, throw out effective, throw in behavioral. Okay, and let's just do one more, analyze, compare means, one way and over, throw out behavior. I want to throw in cognitive, then I want to throw out access, and I want to put in login frequency. And we go, okay. See, so it's got all the tests like that. Remembers, now we can go file, export, and we're just going to override that other file. We go, okay, yes, okay. So ANOVA is very commonly used to do this cross tabulation. So now if we go to 2024 internet and we open this access cog, never mind about all the gobbledygook. Now it shows you, for the first one we compared, is there a significant difference in access in terms of cognitive? You can see that it shows you that SIG is significantly different. So these are the important variables that you want to know, and these mean and standard deviations you're going to report on. So I'm just highlighting them so you can see. And then you go down to the difference. So it shows you that these tablets and mobile are significantly different from PC. It also, because there's that little star there, it shows you that this is the postdoc test, by the way, the Bonferroni, shows you that tablets and mobile are different from laptop. And then it reverses it. So tablet is different from PC and laptop, and mobile is different. So it reverses it. So you don't need to look at these, because it just reflects, this is minus, minus, and this is positive, positive. And this is minus, minus, and the minus, it doesn't mean anything. So it just inverts the results. So that's the differences. So therefore, you know, my students actually do these tests in their BTech or advanced diploma. So what I would do for them is, I'd say those are the lower ones. And when I give them their stats, and even my master's and doctoral students, then I just do that. I highlight it. I highlight the figures for them to show them that these are the lower two and these are the more positive two. And then if you go to the next lot of results where we compared effective to behavioral, you can see if you go to the Bonferroni test, in this case, tablets is different from PC, laptop is different from tablets, and all of them are different to tablets. Okay, so tablets is, let's have a look. So this is a hang of a, let's go to the, where are the means? Here are the means. So tablet is the most positive. It's different to all of them. But if you look at mobile phone, let's go to the mobile phone, was also different from tablet. Oh, so yeah, so that's the relationship, really. It's a tablet that was more positive for these, for all of these. That was the relationship. And then you worry the F and signig was also significant at 0, 0, 0. And yeah, so those are the difference. And if you go to the next one, what is the difference? Significant? Yes, 0, 0, 0. F value also 8, quite significant. Where was the difference? PC was different from all of them, and laptop was different from PC. That's a nothing finding. I would report on those three versus PC, because laptop and PC are similar, and that's just the invert. So we're saying PC is different from the mobile devices. So PC is different from these three at a significant difference. And then lastly, frequency, is there significant? Yes, 0.3037. So it's just significant. P-value, F-value, you can see is much lower, but it's still significant at P equals less than 0.5. Where is it finding the difference? It's finding multiple times a day is different from people who access it 2 to 4 times a week. So if we go up here, multiple times a day is more positive than 2 to 4 times a week. That's where the significant difference is. So that's what you would report on. So if there's a significant difference, you look significant difference, then you go and see where the significant difference is located, and then you go to the mean values in order to see, okay, which way around is it? So the one with the highest means is the positive and the lower means is more negative. Now you need to write this up. So what I do is I run all the tests, the 21 tests, you put the p-value here. Those where there's significant difference, you put the asterisks to indicate the level of significance. So 3 stars for 000 and 001, 2 stars for 0, just to show you this. 2 stars if it's between those values, and 1 star if it's between those values. So we'll close that now. Then you need to write it up. So the only significance you found was, so you can now answer your research questions. Was that research question? There's no difference. That was your first research. Your second research, is there a significant difference in terms of tourist actions? Nope. Nothing. Different platform you used? Nope. Nothing. In terms of different social media characteristics? Yes. Across all that researcher's question. In terms of gender and age, are there any significant differences? Nothing. So you see, and you write that up. And how do you, but you discuss that then later. But in your findings section, you'd say respondents use tablets, you put the mean and deviation, mean and standard deviation values, and mobile phones, mean standard deviations to access social media showed more favorable significant cognitive attitudes. You put the F value and the P value. It's always P equals less than 001, even if it was 000, that's just how you report it, towards the Cape Town attractions in comparison to laptops. And you put the means and standard deviations. And then in the same way, you'd write up the rest of the findings. Log on frequency, you'd write it up. Okay. Right. Are you still alive? I've got 2 or 3 more tests to show you. I'll probably go on another 15 minutes. Are you still okay? Yeah, I am recording this, so if you're brain dead at this stage, Frank, yeah.
All good, Prof. All good.
All good, great. It is a lot to take in, but that's why I record it. And as mentioned on the top of the notes, I am recording this session and I will put it on YouTube and on Blackboard as well. But the previous one I ran at Autumn School, there's the YouTube video link. And as I said, this is on Blackboard. You can download it from the PG group. Otherwise, you can drop me a mail and I can send you this. And I will upload this video on Blackboard, and then later on, I will upload it on YouTube, not immediately. So now you can do cross tabulation using, but this is tedious because you have to do this in 21 tests using ANOVA. But there's another way to do it where you only need to run the test 3 times. And it doesn't calculate, it doesn't use ANOVA. Instead of ANOVA, it uses a chi-squared difference test. But it will give you similar results, but not the same results. So sometimes you do ANOVA and then you do the GLM, generalized linear model, to see which one gives you the most significance. So you can manipulate stats by using different tests because they often give different results. So let's do that. So now you've answered all your research questions. We haven't got to the hypothesis yet. I see I've gone to regression here, but I don't want to go to regression. I first want to go to the GLM. I'm going to jump down. Validity, regression. Oh, where did I do it? Have I skipped it? T-tests, ANOVA, reporting ANOVA, generalized linear model. So the ANOVA is limited. You have to examine it one at a time. So one needs to conduct multiple tests. However, multiple analysis of variance, MANOVA, is in the one way I don't use it. I prefer to use a generalized linear model, can be utilized to test several independent variables at the same time. So you only need 3 tests as opposed to 21 ANOVA tests. The generalized linear model uses the world chi-squared difference, a similar principle to the 2 tests. But yeah, again, it only shows the significant difference between groups. So you need to use the Bonferroni postdoc test to show you where the difference is. Hence, the GLM is an alternative. So how do you do the GLM? And my BTEC students use a GLM, or advanced diploma actually use this in their data analysis. So you go, yeah, we don't want this. We go, no. And let's run the GLM. Again, it's not difficult to run. You go analyze, you go to generalized linear models, you go to generalized linear models. Now there's things, different tabs above that you need to. So under response, the dependent variable we check in is cognitive. So you take it across. You click on predictors. The predictors are all the research questions. So we want to test region, attraction, and social media sites. And we want to test access, login, gender, and age, right? Those are the 6 variables that we're testing. Then you go to model, you just block all of these factors, you click shift, you move it across. Estimation, there's nothing. Statistics, we want to do nothing there. means, you want to again block these variables that we want to run. We move it across. And for the, we're doing a pairwise postdoc test. So you just change each of these to pairwise. If you don't, it's not going to show you where the significant difference is afterwards. It will just show you if there is one. And then at the bottom, you want to change this to the Bonferroni. Okay. And now you're ready and you run. And now it's going to do, it gives you this nice table at the beginning, giving you, if you want to write a journal article, the frequencies and percentages of your responses, but that's not what you want to use. So we can do all 3 tests. So we just go, now you want to do the next test, you go analyze, generalized linear model. It's going to remember everything you've done. You just go to response, you take cognitive, you put in effective, done. Analyze, you go to the next, generalized linear model, take effective out, put behavioral in, and there you go. Instead of doing the 21 tests, it's taken you like 1 minute to do it. Now we can export this so we can play with it. File, export, browse. We want to just stick it under there again, internet, and we want to just say call it GLM. We've done all 3. Save. Okay. And it's going to export these 3. It'll take a bit of a while because it's a lot of stuff it's exporting. Okay. So if you go to internet here, you've got your new file. Okay. So never mind about all this gobbledygook at the beginning. So it's done the first one. So the first thing you're interested in here, it gives you this nice descriptive stats, you know, exactly in percentages, but you could easily generate that. But it gives you the mean and standard deviation, firstly, of the overall cognitive, this 3.14, you know, it's the overall cognitive mean, you know, combining all 6 statements. So that's a useful stat that you can use. And then it shows you, is there a significant difference here under the omnibus test? Remember, this mean is under the continuance variable information, so you can extract that mean and standard deviation from it. It gives you the omnibus test, which means that out of those 6 independent variables, these variables, how many? 1, 2, 3, 4, 5, 6, 7 of them, there is going to be something that's significantly different. So the overall significant is 0.6. And then it gives you a summary. So remember, the Wildcard test just shows you if there was a significant difference. So it shows you that there was a significant difference under just this one, how often you mostly access. Under Nova, there was also a significant difference here, but now it's no longer here. So it shows you how do you mostly access, there's a significant difference. Now it shows you the Bonferroni post-test below. So you scroll down through all of this. And now for each one region, it shows you the same ANOVA type data, the mean and standard deviations, and the postdoc test. Is there a difference? No. And this 0.18 is the same as the 0.18 year. So this table's the summary, and then below it shows you each test in full that it ran all at the same time. So there was nothing here, truest attraction, nothing here, you know, no significance here. The next variable, yes, this is where the significant difference was. And what is it? It is laptop is different from tablets and mobile, and PC is different from laptop. Remember, these tests below are the duplicate. So tablets and these two, so it was the same result. Actually, these two are different, not both from these two, but, and you would report on it the same way as you did ANOVA. That for the cognitive attitude, tablets and mobile were more positive cognitive attitudes towards social media marketing communications than PC and laptop. And you'd give the mean and standard deviation. And then you could scroll down. So the rest you can ignore. You can go down to the next test for effective. So here's the next test below for effective variable. Here it gives you the mean and standard. It gives you that. It gives you the yes, there is a significant difference in the 7 variables under the omnibus test. And now you can see where is it. It's these two again, the exact same results as ANOVA. These two were significant. And then you could scroll down to these variables, ignore the rest. You're not interested. If it's not significant, you're not interested. You don't report on it. And here it shows you again a similar, it's tablets different from everything. Yeah, tablets different from everything. So tablets the most positive, and it's different from the other 3 variables. And if we go down to log on frequency, 0.09. So here's an interesting thing. Sometimes when it's not significant at 0.001, you see there's no A's here. It's not showing you where the significant difference is. So then in that instance, you need to check your effective and your behavioral if there are also significant differences. But if you look at the mean values here, the highest mean is generally what's significant. So the highest mean is that multiple times a day. And you remember from the ANOVA test, that was also different. And the lowest mean looks like 2 to 4 times a month. So you would just have to say take the highest and the lowest. But if you did other tests and the others maybe showed that, that was also significant for the cognitive and the behavioral, then you could just also put it in here because it's also below 2. And therefore, they're more positive in terms of their effective attitudes towards social media and tourist attractions when they access it more often than fewer times. And then you could go to lastly the behavioral. And here's your tests. Mean, overall, there is a significant difference. Where's the significant difference? So again, it is these 2 variables. Okay, so we're not going to continue. And then how to write this up, don't save. If we can just go to the notes. So how do you write it up? So you can create a table like this with the overall means and standard errors. Okay, so you can say based, and I say the GLMs showed that those significant differences. You explain what you did, and you can write up the means and test like that of the overall attitudes, and then you do a table exactly like ANOVA, stating those that were significant. The only difference was that this was significant in ANOVA and not significant here, but sometimes it works. And I missed one. Region was significant under behavioral as well. Region, I missed that. So let's just check where we are. Let's just go down. I closed that test, but region was different. Let's just see what the region was. Access, and you just write it up in the same way, just saying the significant at peak was less than 0.01. You give the mean and standard errors. So there's no standard deviations in GLM. They have a standard error. It's a bit different, and I'll tell you why there. But I want to see log on frequency. You write up region, a significant difference in respect of region. South African tourists showed more favorable behavioral attitudes than International tourists, how's that? Local tourists were more positive in terms of behavioral. So if they were exposed to social media, they were more likely to go to the tourist attraction than international. It makes sense because the international tourist needs to catch a plane to get, or a boat to get to South Africa, to get to the Cape Town tourists, where locals are right there. So if they see something, they can immediately go to it. And yeah, that's how you write it up. You can just look through that yourself. Okay, we've got a few more things to go. We will go till 7. So if you need to go, you can go. It's always my case that I always go a bit over, but it's just not possible to do this faster. You may think I'm going fast, but yeah. So you've answered all your research questions now used in either t-tests, ANOVA, so you know what influence, if region has an influence. And yes, it was found to have an influence under behavioral attitudes. In other words, tourists were more positive from South Africa for the behavioral aspect. Nothing was found for this research, nothing for this research. Usage characteristics, yes. How you accessed it and how often you logged on played a role in all instances in ANOVA and not GRM. Demographics played no influences. So you've answered the research questions. Now we want to look at the hypothesis. Does cognitive have a positive influence on affective? Does cognitive have a positive influence on behavioral attitudes? Does affective have a positive influence on these? And so there's a few steps we need to do to get there to answer those hypotheses. So let's scroll down. So now we need to do regression. And this is the nitty-gritty. Most people want to test hypothesis. So regression determines the strength of the relationship between independent and dependent variables in a straight line. So that's a theory. Linear regression uses the estimated standardized beta coefficients to test their value. Yeah, and usually there's a variance value of R squared as well. So yeah, I'll show you how to do this. And it's very simple to do this, to do regression. And let's just do it. So that's why we computed those variables. So we can close this. Nope, we won't want that. So let's just do this. So you go analyze, you go regression, you go linear regression. Now we want to compare the dependent variable is affective and the independent variable is cognitive. Let's just check that I'm right. Yeah, independent is cognitive. We want to compare cognitive into affective. The dependent variable is what feeds, the arrow feeds into it. And you just go, okay. And let's do all the tests. Analyze, that you want to do regression, linear regression. Now we also want to test the cognitive into behavioral, because that was another hypothesis. We go, okay, and we go analyze, regression, linear regression, and now we want to check, cognitive goes out, and we want to check affective's influence on behavioral, and we go, okay. Has that done it? Affective in 1, 2, 3, and now we just go file, export. Let's just change it here without going in. We'll just say regression. And go okay. So it exports it. It's easier to work in Excel than these sheets. We go back in. Here's the regression tests. So let's show you what we are looking for. So firstly, we're looking at the R value. The R value is the beta. It also shows it here. Shows it in 2 places. The beta value, 0.5, that's strong. You know there's going to be a significant difference because the most it can be is 1. So does cognitive attitudes have an influence on affective? In other words, if you've got positive cognitive attitudes, is it going to have a positive influence on the affective attitudes? The answer is yes, because it's significant at p equals 0, 0, 0. You also have a high t value, which is similar to the f value, or there's a high f value, but usually you report the t value with regression, and that's a high t value. So, And then you also look at the R squared, the amount of regressions a bit low, but it doesn't matter because it's significant. Ideally, you want that above 0.5. So these are the values you're going to report. Yes, you can say there is a cognitive as a positive influence on affective. The standardized beta efficient is 0.057. The t-value is this, a significant value is this. Then if we look at the value of cognitive on behavioral, yes, there's a significant difference. The R squared is also a bit low at 25.9%. But if we look at these three values, so this 509, remember, is the same as that 509. And the t-value is also good. And there is a significant difference. And if we look at effective on behavioral, 577 is the highest. There's the standardized beta, 0.57. T-value is high. And the regression value is a bit higher at 333. So these are the important values. How do you report on this? Let's go. So reporting, the tourist exhibited a positive effect on affective attitudes. T equals, so you report the T, the beta, and P equals 001. Likewise, positive influence of behavioral, cognitive was on behavioral. You give the T, the beta, and that. And the same affective, you give the T, the beta, and the standard deviation, just like I showed you. You see I'm highlighting these three values. Right. The only other value you're interested in is the regression, and I'll show you that now. Hence, hypothesis 1.3, 1 to 3 are supported because that's what you said. Cognitive has a positive influence on affective, cognitive has a positive influence on behavioral, and affective has a positive influence on behavioral. So you found it, you proved it statistically. That's how easy it is to prove a hypothesis. You can say additionally, cognitive and affective. So the cognitive and affective were both feeding into behavioral, explain 0.38 of the variance. Where you look at them both together. I didn't show you that. So to get the collective variance on behavioral, you can so if two variables are feeding in, to get that variance, you'd go analyze, you'd go regression, linear, dependent variable, and then you see you can add a second variable there, cognitive. You see, you can add both, because when two variables are feeding into one, to increase the variance, you would go run the test, and then you can see that the variance is 3.83. It increases a bit, so you don't report on them independently. So I didn't show you that. I'm glad I saw that. So is 38.6. So when you compare both cognitive and affective are going in here, so the variance, you just say R squared is the variance. Ideally, it should be above 0.50 for just normal social sciences, but, you know, it doesn't matter. No one's going to quarrel. What is important is all the beta values are actually good. But even if the beta value is 0.2, as long as it's significant, that's all that counts. So this is what your diagram would look like then. You have your conceptual framework in chapter 1. In chapter 5, you give your conceptual framework. You say cognitive, you report the beta value there. 0.509 is significant at P equals less than 0.001. They all were. And this is the cog to affective. That's how you write it up. And then you write it, you know, yeah, and that's how you write it up then. Then there's just two other things I need to show you is factor analysis and how to do validity. So factor analysis reduces the number of variables into smaller groups. So it checks, are your 6 variables for cognitive, you know, are there intercorrelations between them? Do they fit together? So you can conduct confirmatory factor analysis as per Palant, and I will illustrate the principal component analysis, basically the same thing. So you need to assess if the data set is suitable for analysis. So you need to have enough respondents. So you've got 18 items, 18 Likert scale items. So generally the rule of thumb is 18 times 10. Therefore, you would need at least 180 respondents. But if you're going to do a lot of cross tabulation, then you need to have more respondents. So for quantitative statistical analysis to work, you need to have enough respondents. Like if you've got a variable with 10 cross tabulation factors and you're only doing 180, the chances are you're only going to have a couple when you do the cross tabulation. So therefore you would need to go bigger. Other factors you consider is the Kaiser, we'll explain it, the KMO and the Bartlett's test of adequacy, but yeah, we'll get to that later. So how do you do the validity? So it's quite a few steps, but this I do fairly regularly. So I'm going to take you through how to do it. And so this groups variables together and is very important to get your validity and to get the rest of the variables you need for this table. So let's go to factor analysis. You go analyze. Well, we don't need this anymore, so nope. So we come into the end. This is the biggest thing and the higher grade stuff that doesn't always work for everyone's stats. If your data, if you haven't created good constructs, you're going to run into big problems here. So it's important to take time in developing your questionnaire. So you go data, mention reduction factor. You want to take your 18 Likert scale questions across. Descriptives, you want to select this KMO because it's something you can report. You click continue. Extraction. See, if you run into problems and it's now giving you 4 or 5 variables, you can fix it and say, I want 3. Or if you've got 5 constructs, I want 5. But these stats do work out. We're going to take a scree plot. We're going to take agent value. Oh, we don't want to continue. Rotation, Promax. Oh, we do want to. We click Promax, continue. Scores. We're going to click save variable. So that means all the constructs it creates, like we did that where we computed the cognitive, the affective, and the behavioral, we computed them and we forced them together, but this will then save the variables it believes goes together. So we've clicked save variables. You don't do that initially while you're sorting it out. Options, we want to just express the sizes to 0.4 for now. We'll change it later because it makes it easier to check your pattern matrix. You click continue. Okay. Oh, and then you click OK. And it will take its time to run these stats. Unless I've done something wrong. Okay, let's just check what things happening. Data, factor. We've got all these variables. Descriptives, initial increment, that's fine. Continue. Extraction. We don't want to. Oh, has it eventually come? Oh, it just took a long time to process that. Here's my data. Let's just export it, file, export. We'll just call this FA for factor analysis. Okay. Okay, it's taking its sweet time. Go in here, there's the FSA. So now the variables that we're interested in. Okay. Firstly, we want to report on the Bartlett tests. So it's 0.95, it's great. And the Bartlett, that's the KMO, is great. And the Bartlett's test is significant. So you just report on that. It doesn't mean too much. After you've done the test, you say the KMO was utilized to measure the sample inadequacy. It had an excellent value of 0.950. The factorality and correlation index via Bartlett's periodic test was used to determine the various scale correlations and was found to be adequate at significant. So this is gobbledygook. I mean, I don't even truly understand what all of this means, but it's, you know, you just need to understand that anything above 0.87 is good. And if this is significant, it's good. It shows that there's sufficient correlation. Next, you can have a look at the, we can close all of these. Don't save, just to make it easier, close this. Don't save. Okay, next you look at, and I can make this a bit bigger. Communalities. You don't usually report on it, but as long as it's above 0.3, that's good. Okay, then the total variance explained is the crux of the matter. So it's taking your 18 variables, and these variables should be above 0.1. So it shows you there's 3 variables, which is excellent, because what is you have 3 variables: cognitive, affective, and behavioral. So that's what you want, and these values should be above 0.1. And this whole thing you can cut and paste into your thesis. And to show you, so commonalities I don't report, and it should be above 0.3 I give you. Secondly, you look at the variance explained, and the PCA, which is this, which I've cut and paste out. Principal component analysis produced 3 variables with values variance explained of 7, 1, and 1.3. The total variance explained was 57, which is fine. It's above 0.5. That's great. And then you can say the scree plot, which I'll show you now, showed a change between 4 and 5, which means it supports that there should be 3 variables. So the scree plot looks like this. If we just go here again, this is what it looks. And there's a kink between 4 and 5. So it goes and there's a sudden change of direction, which means you retain these 3 factors, which is what you want. So if we go here, you'd say, so you'd cut and paste this whole diagram in like this, and you'd give the total variance, which is 57. That's where you take it from. You've got these notes. The scree plot supports these 3 variables. Now you go to the pattern matrix, which is the crux of the matter. And this really shows if you're, we don't want to be there, we want to be in the Excel. So if we scroll down, here's the pattern matrix. So it shows you that these are what's called factor loadings. These 6 variables from the cognitive variables are all grouped together, which is perfect, which is exactly what you want. They're all above 0.6. As long as they're above 0.5, you're happy. You're happy to retain. If they're below 0.5, you may want to start throwing out variables. And then you can see your 6 effective variables are fitting together, which is perfect. And your 6 behavioral variables are fitting together. So these stats worked out perfectly. In reality, if you haven't created your questionnaire, this can be a mess. You may need to throw variables out and rerun it until you get it to fit. So these are called factor loadings, and you copy and paste them out. And in this, by the way, you rerun the test when you can rerun the test, because you don't want to just put these variables in this table in your thesis, although in a journal article, you would just put these variables like this. So just to show you quickly how to rerun this so that you get all the values instead of those just above 4, you would go analyze, you would go to dimension reduction factor, and you would just change the setting under not descriptives, cancel, extraction, nope, cancel. I think I want to be by scores, nope. I want to be by options, yes. So you just uncheck that suppress values and you click continue. You click OK and you run it again. Then you'll see your pattern matrix. You don't do the component, you just look at the pattern matrix. You see it gives you the same 6 values there, all above 0.5, and these are like just gobbledygook. But you always run it first without all the values. Then you cut and paste this whole table in, and you just highlight in a different color the variables that fit together like I've done there, right? And then you say the factor loadings of the cognitive, affective, and behavioral scales range from 0.533 to 0.866, so the variables that fitted together, which exceeded 0.5, therefore indicative of convergent reliability. So that's what factors loading. And you take these variables and then you cut and paste them under factor loadings for your cognitive, your affective, and your behavioral. So that's convergent if they're above 0.5. The 2 variables we haven't done is average variance extracted, which is another convergent reliability, and composite reliability, which I've got a little table to help you. So you report on that, and that's it. You're done. You've extracted everything else you need from this table, with the exception of these 3 values at the end. These 3 values you need in the component to help you compute your different convergent and divergent validity, which is the last thing I'm going to show you now. So you've created that, then you cut and paste all these values in. The two values we haven't done is the AVE and the CR. CR is composite reliability. It's additional reliability measured to composite reliability. AVE is an additional value to the factor loadings for convergent reliability. And we still, I just to give you a whole lot of other explanations there. So now we need to do validity, okay, which is the last test, which refers to the degree which a stale construct measures what it sets out to set. That's why those constructs, the Likert scales, must actually, people often put statements and you say you're measuring awareness, but you have a statement that's talking about purchase. Does purchase fit with awareness? No, they're two different constructs. So you need to make quite sure that you select them carefully. And then you need to calculate convergent reliability. So you've done that for the factor loadings, must be above 0.5. We haven't done the AVE yet. Discriminant validity, I'll show you how to do that. You take the square root of AVE and it needs to be larger than each of these values. And I'll show you how to do that. So SPSS does not make provision for AVE or discriminant validity. So with Dr. Corey Ace, we developed a template in order for you to use. And it is also on Blackboard as well. And so the template for validity, I haven't got anything open here, close, don't save, looks like this. We just need to go back into that. And validity calculation templates. Right, this is what it looks like. So it's set up to measure like up to 7, 5, 4 variables, but you can easily just expand this by dropping things down like that, if you have more than however many constructs. But so what you need to do is cut in so you've got your first component, cognitive, your next component, effective, and your next component, you could have more. So I've set up the scale for up to 10. And as I say, you just drag things down and you have behavioral are your 3 factors or components, right? So what you need to do now is we need to actually just open this factor analysis again. And I've got it here, fortunately. So now we go to this, and so what you need to do is, okay, I've exported it. So we need to take the cognitive. So here's the 6 cognitive. No, it's behavioral. Where's cognitive? Here's cognitive right above. You take these 6 cognitive, you go copy, you go into the template and you line it up there. Paste. It does a whole lot of things. We just delete this one because you don't need it. You've only got 6, right? The count must be 6. Likewise, if you need more, you can always drag it down, So if you don't have, say it's like this and you need 6, you just cancel, you just drag this down and then you've made it 6. So you can adjust this according to the number of variables. Then, so it's A1 to A6. Then you go to the next one. It's going to do all the work for you. The 6 behavioral factor loadings, and if there's low values, it's going to have a bad influence on your values. So, and you line it up with the B1 and you put it in column 2. You click post and it automatically populates. We delete that one, right? And then we take the last 6, which is behavioral, and we go copy and we stick it into this template. And we line it up with the C1 there, and we go paste, and there it's done, the 6. So now what it's done is, never mind about the formulas, it's calculated your AVE. 0.057, which should be above 5, and it's calculated your composite reliability, which is 0.9. Effective is just under 0.5, so that's okay. Composite reliability above 8, and it's calculated your AVE and your composite reliability. So AVE is a convergent reliability measure, and it should be above 0.5. You take these values and you stick it in this where is this table? Yeah, you see, so you stick in the composite reliability and you stick in your AVE values. And now this table you see in just about every journal article you have created. And yeah, you can just write it. Yeah. So here's how to write it up. The table, you can say reliability measure to write up table 6 was undertaken to calculate CR and composite Kronberg alpha. The CR values were all above 8, which is indicative of good internal consistency. By reviewing the AVE and factor loaders, one can develop convergent reliability. The AVEs range from 0.0498 to 0.6 and 0.0533 to 0.88. So you just take the highest and lowest across, respectively, which is indicative of convergent reliability. Then the last you need to do is calculate the divergent reliability. So if we go back to this figure, you'll see that it calculated values here. We don't need to worry about these values, so you can just delete them. And what you need to cut and paste in here is, if you go to the factor analysis, I said you needed to take these values here. So you can just take these two here and cancel. So we need to take these two and copy, and we go into this little template here, and you place them where they fit here. Instead of the 1, you put them there. And then you need to take this one value here, because you don't want to, and you put it here. And there you go. So to measure divergent reliability, we're saying the square root of these AVEs. So I've written formula. You can see square root, make it a bit bigger. The square root, and there as well, I've taken the square root of that value, and I've taken the square root of this value there, should be larger than these component correlation matrix. And are they larger? Yes, they're all in the 0.7s, and these are all below. Then that proves divergent validity, which I do not see in many theses at all, which is problematic. So if we go to the write-up, we say, lastly, I showed you how to do it. Then you say square root of AV attitudes, which is, by the way, for now and Larker's formula. And you say, right, discriminant was considered by taking the square root of AVE for each attitude value. All of the square root values for cognitive effective were larger than the correlation values, which are these, which is indicative then of discriminant validity. And yeah, gosh, that's it. Now you can do everything, you know. We can just close all of these. This template is on Blackboard. Don't save. That was quite a bit. So yeah, I don't know. I mean, it's a lot to take in. It's a killer, but that's why I video recorded, so you can go back and you can watch other people's videos. But basically that should be enough to, you know, for you to be able to do quite a decent level stats for, you know, masters, doctoral, lower levels. It is a lot to take in, and if you don't use it a lot, then you know, you also you know, at each time you have to get back in. But that's when you watch videos. Even when I do certain stats, I download the videos and I watch them each time I do those stats, just to make quite sure I'm doing it right. So I've downloaded a whole lot of James Gaskin's videos, and when I do very advanced level stats, because this is still the simple stats, you get even worse than this, then I have to watch the videos each time. So I'm not sure if there are any questions that you may have or comments. If you don't have access to the Blackboard file, I'll just take your email addresses. You can email me, and I will send you the files, and then later on there'll be a YouTube video. I'll just keep your email addresses and I can send you the YouTube, but you do already have the one YouTube video at the beginning of these notes, or if I send them to you. So if I just go in here, as I say, in these notes, the previous workshop I did, there is a YouTube that covers similar content. But I will also eventually upload this on YouTube, I'm just trying to finish my ad hominem application. So that's due Friday, 5 o'clock. So I need to first finish that. I've got to, in fact, carry on working on that tonight and tomorrow, and then the whole of Friday, and hopefully be done with that. So I don't know if there are any questions or comments, but if not, I'll just stop recording in any event. I'm going to stop sharing. I'm going to stop my recording so that that's available. It is also possible to share this recording